Bismillahirrahmanirrahim. In this session, we will discuss exercise 16.1 from additional mathematics course for O-level and IGCSE students. And this exercise is taken from Sue Pemberton's book, and the topic is Kinematics, exercise 16.1. And this is prepared by Dr. Qamar Saeed, and the contact number is given here. In this session, we will discuss question number 1 to 4. In this video, we will discuss question number 1 to question number 4. Here, first question: a particle moving in a straight line passes through a fixed point origin O, and its velocity v is given as v meters per second, and t in seconds after passing through origin is given by v is equal to 50 divided by 3t plus 2 whole square. So the velocity variable expression is given, and we have to find the velocity of the particle as it passes through the origin at t is equal to 0. So at t is equal to 0, we will substitute t is equal to 0 here, and on placing t is equal to 0 here, this becomes 0, and 2 square is 4. 50 divided by 4 is 12.5 meters per second. So the initial velocity when the particle passes through the origin is, its velocity is obtained as 12.5 meters per second. In a part B, find the value of the t when the velocity is 0.125 meters per second. So this is very low velocity, and we have to find the value of t when the velocity is 0.125 meters per second. So in this equation, velocity is 0.125 meters per second, and we have to find the value of t. So on placing v is equal to 0.125 here, and this becomes 50 divided by 3t plus 2 whole square. On the rearranging it, we have obtained as 3t plus 2 whole square is equal to 400, and on simplification, this bracket opens, 90 square plus 12t and plus 4, because a plus b whole square, on applying a plus b whole square, they come to this, and this 400 is here, and this, on shifting this 400 on the left hand side, then it becomes this. On eliminating it 3 from all by dividing this whole equation with 3, it becomes 3t square plus 4t minus 132. Now factorize it. On factorization, it becomes 3t plus 22, one factor, and t minus 6 is equal to 0 is another factor. So t minus 6 and 3t plus 2 are the two factors. So from this value, the t is obtained as negative, which is not possible. So t minus 6 is equal to 0 is the right option, and t becomes 6. At t is equal to 6 seconds, the velocity will be 0.125 meters per second. So this is part B, and in a part C, find the acceleration of the particle when t is equal to 1. So we have given this velocity v expression, which is 50 divided by 3t plus 2 whole square. So we will differentiate this to obtain the acceleration expression. So we differentiate this velocity, and we have obtained as minus 300 divided by 3t plus 2 and cube. So from velocity, we have obtained this acceleration. So this is the working of differentiation, and we have obtained as minus 300 divided by 3t plus 2 whole cube. And we have to obtain the acceleration at t is equal to 1. So at t is equal to 1, it becomes 3 plus 2 is equal to 5 cube, and minus 300 divided by 5 cube is minus 2.4 meters per second square. Okay, so this is acceleration at t is equal to 1. Now, in order to explain this whole question number 1, we have plotted all these velocity and acceleration so that we can understand the problems well. So at t t is equal to 0, the velocity is 12.5. This is part A. This is question number part 1, part A. At t is equal to 6, the velocity is 0.125, which is very, very close to 0. So at t is equal to 6, the velocity is 0.125. And at t is equal to 1, the acceleration is obtained as minus 2.4 meters per second square. So acceleration at t is equal to 1, which is this is minus 10, this is 0, so this is minus 0.24 at this point at t is equal to 1. So this is question number 1. So now move on to question number 2. Here we have a particle moving in a straight line passes through a fixed point O, and its velocity v meters per second. T seconds after passing through origin is given by v is equal to 6 e power 2t minus 2t. Find the initial velocity of the particle. So the velocity is given as 6 e power 2t minus 2t. So at t is equal to 0, the initial velocity will be obtained. So at t is equal to 0, placing t is equal to 0 here, and velocity is obtained as 6 meters per second, because at t is equal to 0, this becomes 1 and this becomes 0. So v is equal to 6 meters per second. In the part B, find the initial acceleration of the particle. Initial acceleration at t is equal to 0. So we will differentiate this dv by dt, and on differentiation we have obtained as 6 e power 2t, and after differentiating this becomes 2, and on differentiating this minus 2t is becomes minus 2 is here, and after that substitute t is equal to 0, and on t is equal to 0 here it becomes 1. 6 12 minus 2 12, this is 1. 12 minus 2 is equal to 10 meters per second. So the initial acceleration is 10 meters per second. Here the velocity is initial velocity is 6 meters per second. At t is equal to 0, velocity is 6. 0 to 10, here is 6 at t is equal to 0, and acceleration at t is equal to 0 is 10 meters per second square, which is given here. So this is question number 2. And question number 3, a particle starts from rest and move in a straight line so that t seconds after passing through a fixed point O, its velocity is v meters per second is given by v is equal to 5 bracket 1 minus e power minus t bracket close. Find the velocity of the particle when t is equal to ln 100. So initially the particle start from rest. So initially the particle is at rest at velocity 0, and move in a straight line so that t seconds. So the velocity is given as 1 minus e minus t. So this is velocity expression or equation. So v at t is equal to ln 100. So we have to find the velocity at t is equal to ln 100. So t is equal to ln 100 is placed here in place of t. Ln 100 is placed here. On this minus sign may be placed here, and this e and ln cancel out, and 1 minus 100 inverse. So this is 1 over 100. So this becomes 99 over 100 multiplied by this 5, and is velocity is obtained as 4.95 meters per second. So velocity at t is equal to ln 100 is 4.95 meters per second. And question number B, find the value which v approaches as t becomes very, very large. So we have to find the value of v when t becomes very large and t becomes infinity. So at this t placing the value of infinity, this e minus infinity becomes 0. So 1 minus 0 is equal to this 5. So velocity will reach to the 5. So at t tends to infinity, so this is e minus infinity is 1 minus 5 into 1 minus this infinity is 0. So 5 into 1 is 5 meters per second. So on approaching t tends to infinity, the velocity will be 5 meters per second. In a part C, find the acceleration of the particle when v is equal to 4. So when v is equal to 4, in place of velocity we have placed this value 4 is equal to 5 e power minus t, and at this value this 5 divided by here, and we have to find the value of t. So we have modified it accordingly, 1 minus 4 upon 5. So e power minus t is equal to 1 over 5, and on taking log on both sides, so minus t ln 1 5. So this becomes ln minus ln 5. So this minus will go out with this one. Ln 1 is equal to 0. So t is equal to ln 5. So t is equal to ln 5 is equal to t is equal to 1.6094. So t is obtained as 1.6094, or t is equal to ln 5. So we have to find the acceleration when velocity is 4 and velocity is equal to 4 is obtained at ln is equal to ln 5. T is equal to ln 5, which is equals to 1.6094. So we have to find the acceleration is equal to dv by dt, and on the differentiating it, so this first part becomes 0 and the second part is 5 e power minus t minus 1. So this becomes 5 e power minus t, and here in place of t we place ln 5 on nl 5 here. This minus sign can be placed here, minus 1, and this ln will cancel, and this 5 inverse. So this is 1 meters per second square. So acceleration at t is equal to ln 5, where the velocity is v is equal to 4, acceleration is obtained as 1 meters per second square. And we have to sketch the the motion of the particle. So the velocity graph, so we have to draw the velocity graph. So we have drawn it a sketch in a simple rough sketch. Here we have plot it again with some software. Velocity is given in meters per second, and at t is equal to 0 the velocity is 0. At t tends to infinity the velocity is reaching 5, and at 1.69 or ln 5 this velocity is 4 here, ln 5. This is ln 5, which is equals to 1.6094. 1.6094. At 1.6094 the velocity is 4, and at the same time the acceleration is this 1.6094. The acceleration is obtained as 1. Here the acceleration is 1. 0 2 acceleration is plotted here. So this is 1. So same it is verified here. Now question number 4. A particle moves in a straight line such that its displacement s meters from a fixed point O on the line at time t second is given by s is equal to 9 bracket ln 3t plus 2 bracket close. Find the value of t when the displacement of the particle is 36 meters. So at s is equal to 36 we have to obtain the value of t. So in place of this s we place 36 here, and on simplification we have obtained as this 36 divided by 9 is 4 ln 3t plus 2, taking e power on both sides. This becomes e power 4, and this is 3t plus 2, and 3t is equal to e power 4 minus 2 and divide by 3 here. So t is equal to e power 4 minus 2 divided by 3, or it may be write down as t is equal to 1 over 3 e power 4 minus 2. In a part B, find the velocity of the particle when t is equal to 1. So we have to differentiate this. This is displacement or distance. So this displacement, we have to divide it by we have to differentiate it. So ds by dt. So on differentiation, we have obtained as this 9, and this ln becomes 3t plus 2 in the denominator, and this and after that this 3t will be differentiated with 3 in the numerator. So in the numerator this is, so on differentiation this s, it becomes this, so 27 upon 3t plus 2, and at t is equal to 1, this velocity is obtained as 5.4 meters per second. And part C showed that the particle is decelerating for all value of t. So this is velocity. So we will again on differentiation it again once more time. So we will obtain the acceleration. So acceleration is dv by dt. On differentiating this velocity term, we have obtained the acceleration as minus 81 divided by 3t plus 2 square. So we can write down this minus 81 here, and this term is here. So we can see this is always positive. So this is always positive, and this multiplied by this negative term, so it gives an negative acceleration for all the time. So for all value of t, this is positive, and when multiplied by this value, it becomes always negative. So it shows that the particle is decelerating all the time. So here we can see this, and we have also plotted it for the displacement particle, displacement from this to this part. In a 36, in the first part, it was asked the value of 36 at, we have to find the value of t, and at 36 the value of t is obtained here. At 36 it becomes very close to here side somewhere, because 20 and then 30 and 36 is very close to 40. So at near this value it will be here, which is equals to 1 over 3 e power 4 minus 2. This can be calculated. And in a part B, we have to obtain the value of velocity at t is equal to 1. So velocity at t is equal to 1. So velocity at t is equal to 1 is obtained as this. This is 0, this is 2. So this is 1 here, 5.4, close to very 5. So this is 5.4, which is here meters per second. And part C, we have to show that acceleration is always negative. So in acceleration, we see that it is always below 0. So this is always negative. This is question number 4, part C. In the next session, we will discuss question number 5 to 9.